Hello and welcome. I am Hyperbola and our today's topic is isometric projection. So let me give you a brief about what do you mean by isometric projection. So when you try to convert your two-dimensional views into three-dimensional objects, it is nothing but your isometric projections. So let us first understand isometric drawing. So in the 3D drawing of an object, all the three-dimension axes are mutually perpendicular at 120 degree to each other. So as we know, the total circular angle is what? 360 degree, right? So here iso means equal and degree means 120 degree. So we have made a three axes of the dimensions as 120 degree apart, and we will be having one drawing which is nothing but your isometric drawing. So let us understand this isometric drawing. So as you can see, I have two objects on my left, and these two objects having three axes x, y and z. When I try to draw these two objects by keeping your three of the axes at 120 degree apart, it is known as your isometric drawing. Iso means equal or similar. As you can see, three of the axes have a similar angle between them. So that's why it is known as isometric drawing. Isometric drawings are actually drawn to understand the shape, size and the overview of an object before its production. So let us understand some important terms used in isometry. So first, isometric axis. As you can see, we are having one three-dimensional object which is also known as your isometric drawing of a cube. So the center point of this axis are shown as your A, and there are three axes from A. First is B, second is N, and third is H. So as you can see, the three lines are there, AR, AD and AH, which are meeting at common point A and which are 120 degree apart. So these axes are nothing but your axes at equal degrees apart. That's why these axes are known as your isometric axis. Thereafter, isometric lines. Whenever we try to draw lines parallel to all of these three lines, AL, AD or AH, in anywhere in the drawing, then this line must be known as your isometric lines. Thereafter, isometric planes. Whenever we try to generate any planes by the help of these isometric lines, then we might have the planes generated which are also known as your isometric planes. Now, isometric scale. So whenever we try to observe any object and when we try to draw that object into three-dimensional view, the dimensions get reduced in particular fashion and in equal proportion. When we try to draw this phenomenon into a straight line, we might observe one scale generated, and the reduction here is of the factor 0.815, or you can say 9 by 11. So in the subsequent section, we might be observing the process of constructing the isometric scale. So let us move ahead and let us check the process of isometric scale. But before going ahead, let us understand what are the types of isometric drawings available. So there are two types. First are known as your isometric view, and second are known as your isometric projections. In isometric view, they are drawn with the true dimensions and with the true scale. So you will be using your normal ordinary scale, and you will be plotting your actual object into your drawing sheet, and this is nothing but your three-dimensional view of an actual object, and which is nothing but what? Isometric view. What you are viewing, you are drawing directly. That is a simple term. Now secondly, isometric projections. You are actually taking the projection of that particular object, so that means its dimension may get reduced in the fashion while drawing into your drawing sheet. That's why this kind of drawings are also known as your isometric projection. So here your drawn dimensions are drawn with the help of isometric scale, which we are going to generate next, but your dimension would be reduced dimension as compared to the real dimension of an object. So let us now construct your isometric scale. So what we need to do, you need to draw one horizontal line. Onto this horizontal line you need to construct two lines, first at 30 degree and second line at 45 degree. The first line is also known as your isometric scale, or onto which you will be showing your isometric lengths, and second line which is known as your true length line, or you can say a normal scale. So normal scale is nothing but your ordinary scale which we are actually using to draw or measure your distances. So what we need to do, we need to just draw and take the particular dimension onto your normal scale. So let us take the particular dimension onto your normal scale as 0, 1, 2, 3, 4. Like these are the dimensions taken from your normal scale. Now let's draw vertical lines from each and every point in order to get the dimension onto your isometric scale. So as you can see, there is one vertical line drawn from each of the portion by a red line, which is showing the conversion of your original dimension into the isometric dimension. Now we have new scale generated, which is shown by a green line, which is specified by iso line. So while drawing these isometric projections, you need to use this iso scale. And while drawing your isometric views, you will be using your normal scale or your ordinary scale, or you can say in this diagram you will be using this black scale, which is of true length. So easy. So now let us understand, if your dimension is of 4 centimeter or 4 mm. So if your dimension is 4 mm, the actual dimension of an object is 4 mm, then you must find out 4 mm onto your true length, which is the actual length scale. Now if you need to draw that object into your isometric projection, so what we need to do, we need to just find out 4 onto your true length, and we need to go vertically down until we reach the isometric scale, and onto your isometric scale you will be having this 4 digit. So you will be taking the dimension of 0 till 4 from your isometric scale, and you will be drawing the object by using now your isometric scale only. So that is the difference, the major difference between your isometric view versus isometric projection. Isometric view means whatever you are seeing, you are drawing with exact dimension, is your isometric view. In your isometric projections, we are actually generating the projection of that particular object, and we might be generating that projections which are actually of a reduced length. So we will be using the reduced length from this scale. So reduction factor is what? 0.815. So if you need to directly transfer your dimension from your true length to isometric length, so what you need to do? You need to just multiply your true length by 0.815 factor. You will be directly getting the dimension on your green scale. Right? So let us move ahead. So now let us see, we will be having some of the planes, and we will try to convert these planes into your isometric figures. What we will do is, we will be having a true shape of the figures, and we will be converting it into a front view and side view of the figures. So let us make one table. So first we will draw the shape into first column. In second column we will be drawing the true views. First the front view or the isometric front view, and second we will be drawing the isometric top view. So here our first object is what? Rectangle ABCD, right? So we'll try to generate the isometric front view and top view of this object. So let us take one reference line, and from this reference line we'll try to generate the isometric axis. So let us generate the first isometric axis for your front view. So this is nothing but your isometric axis H and L. On this H and L, you need to just specify your point B, and thereafter you need to specify A, C and D. You will be having your object created like this. Thereafter, let us construct the top view isometric axis like this. So as you can see, from your point B, you will be drawing 30-degree line on the left hand side, 30-degree line on the right hand side. On this line, you can plot your point A and C, and by that you can produce your top view. So our next object is triangle 1, 2, 3. So let us first enclose this triangle into the rectangle, and thereafter we will be following the similar procedures, and we will be drawing the rectangle first for the isometric views, and then in that rectangles we will be specifying this our triangle. So let us draw this first rectangle, and thereafter let us indicate the triangle by finding and locating the points. Thereafter let us draw the top view of this rectangle, and thereafter let us locate these points by help of your rounder. Very easy. Now let us move to our next object, which is pentagon. So in similar case, we need to generate one rectangle around this pentagon. Let us draw the two rectangular views of this pentagonal rectangle, and thereafter we need to just specify the points on the lines, and we might have your pentagon generated. It's very easy, right? So whenever you are having any different shapes other than the rectangle, what you need to do, you need to just generate your pentagon, hexagon or square or anything. You need to enclose this particular object into your rectangle, and thereafter you need to just redraw the rectangle, and thereafter identify points on this line. You will be having your final views generated. So now let us draw the circle by this method. But it is not possible practically to draw the circle by the method which we have used in our previous examples. So for circle, we need to use a special kind of method. It is known as a four-centered method. So let us understand how do you draw your circle by four-centered method. So first of all, you need to enclose this circle once again into a square box or a rectangular box. So here I will enclose my circle into a square box. Then after I need to draw a top view of the square like this. So let us take the horizontal line and then after draw one 30-degree line on the left, 30-degree line on the right, and we will be constructing this square box, which is also known as a rhombus in our case. After getting the rhombus, you need to find out the midpoint of each and every side, and you need to mark these points as A, B, C, D as you can see. Now let us find out the shortest diagonal of the rhombus and let us highlight the point. So the vertical points are the shortest diagonal of the rhombus, so I have highlighted the point. Now from the bottom point of your shortest diagonal, let us join the opposite sides like A and B. And similarly from the upper side of the shortest diagonal, let us join the points B and C. So we will be having two intersection points. So let us highlight these two intersection points of these lines. So we will be having total of four centers generated. So let us observe the four centers generated. So 1, 2, 3 and 4. So first 2 points are at the end point of your shortest diagonal, and second 2 points are at the intersection of these cross intersecting lines. Very easy, so we have found out our 4 points. So now next task is very simple. We need to take first point and we need to draw one circle. So let us take point 1 as your center and 1A as a radius. Draw one arc until you reach the point B. Now take 2 points as a center, take 2C as your radius and draw the arc until you reach the point D. Now let us take the 4 point as a center, 4C as a radius, let us draw one arc until you reach the 4B point. Then after let us take the 3 point as a center and 3A as a radius, let us draw one arc starting from 3A until you reach 3D. So it is your circle generated by four-centered method. Now let us draw a front view of this circle. So for that, let us construct your square box in the front view. So let us draw one 30-degree line and let us draw one vertical line and let us finish this square. Square is of the dimension of what? Your diameter of the circle. So now after that, what we need to do? We need to just find out the midpoint of each and every line. After getting midpoint, what we need to specify A, B, C, D as a midpoints. Then after let us find out the shortest diagonal. So this is my shortest diagonal as you can see. So on the shortest diagonal, let us identify 2 points. I have identified from any of the points. Let us join the two opposite lines. So first I have joined this point with A and B, and from another point let us join the 2 lines B and C like this. Then after let us identify an intersection point. Let us identify 4 centers 1, 2, 3 and 4. After getting center point, what will you do? You will take 1 as a center, 1A as a radius. Let us draw one circle until you reach 1B. Now take 2 as a center, 2C as a radius. Let us draw one circle like this. Then after let us take 3 as a center, 3A as a radius. Let us draw the circle. And finally we will be having 4 as a center and 4B as a radius. We will be drawing this circle. So this is nothing but your front view of a circle. So you need to compulsory use this method in order to draw a circle into your examination. This is very important method. It is also known as a four-center method to draw a circle, or it is a special method to draw a circle. So let us move ahead. Isometric view of the pentagonal pyramid and standing on HP. So pentagonal pyramid standing on HP, that means your pentagon would be drawn into your top view. So let us draw first the pentagon. So how to draw pentagon? So first for that, let us draw your square. Onto square will be plotting your pentagon like this. So this is nothing but your pentagon, required pentagon, which is resting on HP. On HP means what? On HP there is always a top view. So we have drawn the top view of your pentagonal pyramid, which is a pentagon. So let us construct the pentagon first. So we will be constructing the box on this axis, and on this axis we will be constructing our pentagon. After constructing this pentagon, we need to find out its center point. So for that, you need to find out any corner point and you need to join it to opposite sides midpoint, and you need to find out another corner point and you need to join it to opposite sides midpoint. You will have 2 lines intersecting at any point. This is nothing but the center point of your pyramid. After getting center point, you need to just draw one vertical line which is showing the height of the pyramid. So let us suppose your height of the pyramid is 80 mm, so you need to draw 80 mm vertical line. So after drawing this axis, you need to connect this top point to the each and every point of your base like this. So let us connect each and every point of the base. So here observe, we are not connecting the D point because it is in the back side, so it will be on the back side of the image. It can't be seen into your drawing, so we are not connecting to this point. So this is nothing but your pentagonal pyramid resting on HP. So now let us move to a next thing, a pentagonal prism lying on HP. Same here, having the pentagonal prism laying on HP. Prism means it is having two bays of similar kind. So let us note and observe the procedure for isometric view of pentagonal prism lying on HP. So here pentagonal prism lying on HP. So what we need to do? So observe the procedure. So what we are doing? So first of all, we are constructing the box onto which we will be constructing the pentagon, as you can see. Now then after, what we need to do? We need to just draw the horizontal lines from the each and every point of the pentagon. And after constructing this horizontal line, we need to join the end points of this horizontal line by simple lines, and you will be having this pentagonal prism generated which is resting on HP. So here the line lengths are depending on the height of your pentagon. So pentagonal prism's height must be given. So let us say, for example, our pentagonal prism is of 80 mm length or 80 mm height. So you need to draw the height from your pentagon by 80 mm dimension. And you need to just join these end points and you will be having this final figure. So then after, let us move to see the hexagonal prism is standing on HP. So hexagonal prism standing on HP, that means hexagon is resting on HP. So we'll be drawing the hexagon in such fashion into box. Then after, we must be having the height of the hexagon. So let us suppose 80 mm is the height of the hexagon. So we'll be drawing 80 mm from each and every point of the hexagon like this. And then after having the end point, you need to just connect these end points by the straight line. And you might be having this joint like this, and you will be having this hexagon generated. Very easy. Let us move to our next problem. Now next is your cylinder laying on HP, and second is a cylinder standing on HP. So first let us see the cylinder lying on HP. So for that we might need to draw a front view of the circle by 4 center method obviously. Then after, you need to draw a straight line according to the height of the cylinder or the length of the cylinder. You need to draw the straight line from each and every corners of your box. In order to complete the box, at the end of the box you need to generate another square. Into the square you need to generate a circle by the similar dimension, and you need to just generate the end point of the circle by a tangent line. You will be having this cylinder generated. Similarly, for this cylinder standing on HP, what we need to do? We need to draw a circle in the top view. Then after, you need to draw the vertical lines from your square, and then you need to generate a square box above this point. And after, you need to follow the procedure of 4 center method in order to draw the circle of the similar dimension as that of the bottom circle. And then after, you need to just simply join the end points of this circle by a straight line or a tangent line. You will be having this cylinder generated. Ready? So then after, let us move to create a isometric view of frustum of a square pyramid. Frustum of square pyramid means you will be having one pyramid. So pyramid means what? It's Egypt's pyramid. Always remember. So you will be having apex at the top. So you will be having a single base and you will be having apex at the top. So it is a square pyramid. That means we need to just first draw the square, and then after we need to draw frustum, means we need to cut this square pyramid. So let us see how to draw this object. So this is a view of your frustum of the square pyramid. So in which your bottom would be square and also your top would be looking like a square. So we are having the dimension of square as 40 mm for the bottom and 20 mm at the top. So let us observe the procedure how to start with the square pyramid. So first you need to draw the square pyramid's base. So like this, so you need to just generate the base at the bottom. After this, let us draw the vertical lines from each and every point. So after getting these vertical lines, you need to complete the square at the top of your pyramid. Now we need to draw the top base as 20 mm square. So what we need to do, we need to just find out the midpoint of each of the sides at the top, and then we need to draw the axis like this. And then after, you need to take the 10 mm away from each of the lines, and you need to identify the points on the axis like this. And then after, simply connect these joint points, and these points are nothing but a square with 20 by 20 mm size. After getting this square and the bottom square, we need to just connect the end points of the corner of this both of the square like this, you will be having your final object generated, which is nothing but what? It is a frustum of a square pyramid. So this is your final object. Very easy. Let us move to the next one. So let us suppose this problem is asked in your examination, then how would you think? So we are having a total of 3 views, front view, side view and the top view. So always remember, we will always start with the front view first. So you need to generate front view, then after you will move to a top view and finally we will generate the side view. So let us start our drawing. So first we will construct the axis, then let us observe the front view. So the leftmost side of the view, which looks like a staircase, it is nothing but your front view. So we will start drawing this front view. So let us observe, this is your O point. So this is O point in this figure. So I am drawing this object from your front view like this. So first I will draw vertical line, horizontal, then vertical, then horizontal, vertical, and then horizontal, and then vertical. So this is what I have drawn my front view staircase, as you can see. Then we will try to draw the side view first. So for that, let us construct the L-shaped portion in the side view. Then we know that there are 2 boxes. So let us generate the 2 boxes from these 2 of the sides. So let's draw one horizontal line, second horizontal line, and third line. So these are nothing but the 30-degree lines. So each of the lines which you are seeing at any angle, these lines are 30-degree on the right side, and these lines are 30-degree onto the left side. Then after, let us join these lines by a straight line, by a vertical line like this. So this is nothing but how we can create our 3-dimensional object or isometric drawing. It is very easy. So try to follow these steps, or you can follow any steps. You can first draw your front view, then you can draw your side view, and then top view. Or you can follow the procedure in which you can draw your front view, then top view, and then side view. It completely depends on you. So now let us see one more object. So this is my object. So let us just observe how to draw this object. So first you need to identify your front view. So this is my front view. So I need to draw my front view first, and then I can generate my side view. So let us draw this figure. So first I will be drawing this axis like this. Then after I will be generating this front view portion like this. So let us observe what I will do. I will just draw this line. So this is nothing but your front view L shape, right? Then after I will try to draw this side view line like this. So I will try to draw this side view lines, this line now, then this top line. Then I try to join this line. So I will be completing this object like this manner. Then I draw the vertical line because the side view is a square. So I have drawn the square. Then after, these lines are generated. So I have generated a basic object. Then after I will try to generate the slots and the extended portions. So first I try to generate this square portion, which is extended portion like this. So I will draw this square, and then after I will draw the horizontal lines at the 30 degree, and I will complete this square box. So this is a 3-dimensional view of this square. Then after I will need to draw this slot here. So what I need to draw, so let us observe the procedure how I need to draw these slots. So I will just need to draw vertical lines, horizontal line, and vertical line. And then after I need to draw this slot. So this is nothing but how you can draw your 3-dimensional object. That is all from my side. If you enjoyed my teaching style and enjoyed my lecture, then do not forget to like, share and subscribe to my channel. Keep learning, stay connected. Bye bye.